In this video, we'll continue to look at mathematicians after Euclid. Now, we know that trigonometry was used by the Egyptians and the Babylonians because it shows up in the Rhiine Papyrus and Plimpton 322. But some of the major work that we consider to be done in trigonometry comes from the Greeks as they started to do astronomical observations. Hipparchus was considered the greatest astronomer of antiquity and the founder of trigonometry. He published some of the first trigonometric tables and was able to solve problems in spherical trigonometry. He was able to calculate the Earth's radius and distance to other heavenly bodies, as well as the diameter of the Sun and the Moon, and he's one of the major reasons why we split circles into 360 degrees, as well as using latitude and longitude. Menelaus did much of his work in spherical trigonometry in his major work called the Spherica. The book helped define and develop the concept of spherical triangles, and his theorem helped provide the relationship of the arcs of great circles in the configuration of a spherical surface. Ptolemy helped continue to improve the book of chords, which was probably based off the work of Hipparchus. And a chord, as we know, is the line segment that connects 2 points on a circle. Now, this is important because it's one of the major tools used in ancient astronomy, and was this table of chords to help them determine the measures of different triangles that occur in problems that we often use in trig today. It was through this book of chords that they were able to make accurate measurements and help them understand distances from different bodies. One of his major theorems is considered the opportunity to figure out in a cyclical quadrilateral that the product of the diagonals of that quadrilateral will equal the sum of the product of the opposite sides. So if I look at an example here where I have everything but the diagonal BD, what I know is that 12 times BD will equal 8 times its opposite side plus 7 times its opposite side. I just solve for my missing piece, add my two values, divide by 12, and find out that the segment BD will be approximately 9 5800ths units long. Now, when we look at algebra, we know that algebra has gone through different phases. Where it started was in rhetorical prose, no use of abbreviations or symbols, and that's how it primarily remained until about the 1400s AD, although there was some Greeks that started to improve this. From there, it shifted into syncopated algebra, where we did start to use abbreviations that were adopted for frequently occurring operations and quantities, and that's where we started to transition to symbolic. And our symbolic use didn't begin really until about the 1500s and became prevalent in the 1600s. Now, as I said, the Greeks did use some of the syncopated versions because of the use of Diophantus, who's considered the father of algebra. He helped start that transition even in the early 200s AD. And much of that came from his book known as the Arithmetica, which had 130 problems that was analytically looking at trying to solve both linear and quadratic equations. Now, his solutions only considered the positive rational numbers and left out irrational negative numbers because he considered them at the time useless. So when we talk about a Diophantine equation, we're talking about an equation that allows variables to be integers only. So here's an example that is said to be on the tomb of Diophantus. And it goes through and says that we're going to measure his life. He was a boy, a part of his life. A 12th was added. He married after another 7th. And in the 5th year, he had a son. The son lived for another half of his life. And then he spent the final 4 years trying to console his grief through science. How old was he? So if we take all those components and add them together, we'll get the length of his life, which we don't know. But everything's related to that length of life. So we can think of that as being 1/6 x plus 1/12 x plus 1/7 x plus 5 plus a half of x plus 4 equals x, his life. We combine like terms, we're going to get 28 x plus 9 equals x. Move your x's to the same side, and then divide by the 3/28, and we get that Diophantus was approximately 84 years old when he died. Now, the end started to draw near to the Greeks at around 3 to 4 to 500 AD. Pappus tried to rekindle some of the Greek interest in mathematics, and he wrote commentaries based on Euclid and Ptolemy's works, and it's called the Mathematical Collection, which helped give a guide for some of the existing geometrical works of the time. In the 480s and afterwards, you had Theon, Hypatia, his daughter, and the Neoplatonic school, which helped to try to continue to build on some of that work. Theon remade Euclid's Elements, and Proclus constructed books on the early history of elementary geometry, and he was a commentator of Plato's works. Now, Hypatia was the first known woman mathematician from about 350 to 415 AD. She taught mathematics, astronomy, and philosophy at the university and was well known for her lectures. She created commentaries on Diophantus' work and Ptolemy's. It was because she was considered a pagan that she eventually was murdered by a group of Christians who felt that she'd taken her knowledge and was using it for the devil's work, in essence. And her death, in essence, brought the end to the university.